Thank you very much, David. I may well duplicate some of the previous speakers' points in all of this because actually we're talking about the same subject. Just briefly, the sort of publicity bit. Martin Shaw, I 37 years with an oil major, mostly in the shipping business. I left 2 or 3 years ago to set up my own consulting business, a sort of small consulting business. And when I say a small consulting business, well, I'm it. As I arrived at the desk today, I was asked for my company name, and I said moams, and then they said, what's your name? And I said, if there's anyone else from moams here today, my minority shareholder, also known as my wife, has come to check up on me. I'm going to focus pretty much in this presentation on the F word, the floating word, because clearly the other issues to do with offshore developments like drilling and the likes of that, I'm not expert in. Secondly, I believe the F word is actually the most important word in the FPSO acronym, because if you don't have the floating bit, you've got a sunk FPSO or an SPSO. So my focus will be for the most part on the safety and integrity of the floating bit and how it reacts to the systems. Let me just hope for the best in this one. There it goes again. Yeah, got it. In terms of the presentation today, bit of context. Always got to start with context. That's traditional. I want to talk a bit about what the FPSO hull needs to do. I want to talk about how requirements, field requirements, environmental requirements drive design and drive the integrity of the development. I want to talk about the new build and the conversion issue, which David raised during his piece of the show. I want to talk about a couple of case studies that I'm aware of from my history. I also want to talk about the integrity of the operation and the export chain. So once you're actually into operation, how the export chain can actually create risks, drive risks in the system. And finally, I want to talk a bit about assurance and what assurance actually means. I'm not going to go into detail in this. David covered this much better than I, but why use an FPSO? No pipeline infrastructure in place. It may be deep water. There may be environmental issues that mean you want something that you can disconnect. It may be small fields. It may be reusable. You may want early first oil. Now, I think it's worth saying that the first time I was involved with an FPSO was in the early 90s. And I would say, without being too slanderous, that the view in those days was that an FPSO was a quick, dirty way of getting oil out of the ground quickly. It could be done cheaply because you could use a converted oil tanker and you could bung some stuff on the top of it, and it would get you to first oil pretty quickly. I believe that's changed quite dramatically today. We're now in a world where FPSO is a mainstream development, particularly when you're talking about deep water and the likes of that. And during my presentation, I will touch on that again as we point out the differences that have developed over time. I think it's worthwhile just talking about the basic decision making that's involved in virtually every piece of business, and that is the balance between integrity and economics, the balance between production on the one hand, which includes the performance of the asset, and protection. And this picture, which is one I absolutely love, and I think I've shown it in every presentation I've done in the last 20 years, was produced by a guy called James Reason in a book called Managing the Risks of Organizational Accidents. It's actually worth a read. My team leaders in my last job were all given one as a present and learned that they had to read it. What we're really saying is that if you go too far in looking at production and you don't spend enough time looking at protection, you'll end up with a catastrophe. You'll end up with a disaster. So if you're only interested in production and you don't build the integrity into the system, then it will collapse under the pressure and something horrible will happen. If you go the other way and you get too involved in protection and don't think too much about the production side of things, about the performance side of things, you'll go bankrupt. So the oil company developing an FPSO is dancing between bankruptcy and catastrophe. And his aim is to find himself a safe, profitable operation in the middle. And that is challenging because those two red lines are not static. So the bankruptcy line up there, for example, if it's a small to medium-sized oil company, that line will be affected by the oil price and by other things. So that line, if the oil price is low, is going to come in and squeeze the safe, profitable operation. The catastrophe line is also movable. If you're in a deep water environment, harsh environmental conditions and all the rest of that, then that's going to come in and squeeze you as well. So if you're in a low energy environment with a high risk sort of development, then you could be in a world of hurt. Your options are not particularly great, and you've got to be very careful how you manage things. They sort of that bit there is not is a continuum. You don't just suddenly waking up one morning and go from safe and profitable operation to the extremes. Obviously, if you're heading towards bankruptcy, you're going to get some hints as to the fact that you're heading towards bankruptcy. If you're waking up in the morning and you are suddenly bankrupt, then quite frankly, you deserve to be. You should have noticed. So that's up to people to manage correctly. Catastrophe as well. You don't generally just suddenly waking up in the morning and say, whoops, I've had a catastrophe, I didn't know that was going to happen. Generally, there will have been some indicators. One of the problems you have, of course, is that over a period of time, you may believe that your operation is running absolutely perfectly and everything's absolutely fine. And there may be a few little outlying accidents, and you say, well, these are little outlying accidents. They're just freaks. They're not telling me anything about the way my business runs. When in actual fact, they were the precursors. They were the warnings that would have told you that your business was going to take a quite dramatic nosedive if you didn't do something about it. I think this safe, profitable optimization bit, bankruptcy, catastrophe, I'll come back to this theme again. If you're going to try and optimize, you've got to optimize from a basis of knowledge. One of the most dangerous things you could do, and I think I was speaking to somebody about this earlier, is to decide that you're going to move into the FPSO business and then aim for the most optimized structure that you can produce. Because once you optimize, you're taking away potentially some protection. So if you're new to the business, don't try to be too clever the first time round. Be clever the second time round. Otherwise, you could end up in that world of hurt. What the hull needs to do? I mean, I'm a simple sailor. I believe in the KISS principle. Keep it simple for sailors. And these primary requirements that I've created here are my interpretation of primary. And my definition of primary in this is if you don't do these things, then you'll end up with an SSPO. You'll end up with a sunk SPO. So they are quite critical. I'll come back to how you can optimize later. These rather simplistic definitions I tried to include in a document that BP was writing about what offshore, what FPSOs had to be built to achieve. When you see them, you'll find that people were not amused with my sense of humour. But anyway, let me move on and talk about it. So what is the first thing an FPSO hull has got to do? It's got to keep the water out. I mean, that is actually pretty fundamental stuff. If it doesn't keep the water out, you're back to the SSPO business. So what does that mean? That means that you've got to be able to protect the hull and the tanks and the process plant from, for example, collisions. And those could be collisions from either the supply vessels that service your field, or it could be from a fishing boat or a passing ship where the people on watch have sort of suddenly fallen asleep for some reason, or gradually fallen asleep. Again, you don't do that suddenly. That gets you into discussions about building double-sided hulls and all the rest of that to make sure that you're secure. You also want to make sure that you have sort of corrosion angles handled in the hull. You want to make sure that fatigue is handled. You want to make sure all the basics of building a ship are actually dealt with. So number one, keep the water out. Number two, keep the oil in. Pretty fundamental and straightforward. If you don't keep the oil in, you've failed. So that then gets you back to, as I said, you have a double side which protects the hull. You've got to look at the integrity of the tanks. You've got to look at the integrity of the pipeline systems. You've got to look at the integrity of the transfer system, the hoses that you're going to use to transfer oil to an offtake tanker. So those are also quite important things to deal with. Third one, stay upright. You actually want it to stay upright. That's kind of fundamental. So you need to look at the stability issues that are brought by dumping a large chunk of plant up to 20,000 tons, as David said, on the deck of a ship that may well not have been designed for it if it's a conversion. So you have to be careful that you cover the stability, both in the normal condition, and the normal condition in an FPSO is quite different to an ordinary oil tanker. The normal condition in an FPSO may well include a lot of slack tanks, and slack tanks reduce stability. The abnormal condition is if you're damaged. Will one tank being damaged actually cause the ship to capsize? You don't want that to take place. So you need to make sure that's all dealt with. You want it to carry the weight. It needs to be able to hold the weight of the process plant, both from the point of view of the buoyancy of the hull and also from the point of view of it not actually collapsing through the hull. So carry the weight is pretty fundamental and straightforward. You also want it to stay where you put it. You want it where you left it to be the place that you'll find it again in the morning. So you want turrets and mooring systems that are robust and can deal with the environment that you're operating in. As I said, that is a slightly flippant version, and you may understand why BP wasn't keen that we include this in some integrity management documents. I've called them secondary requirements, and again, that's mainly because they're things that you're capable of doing something to optimize. The primary requirements, if you don't do them, you're finished. You don't have a development anymore. With these things, the secondary requirements are you've got to be able to look at production and export optimization. So you want to be continuing to pump oil. So that means you have to have enough storage for the environment that you're in. You have to have enough storage for the supply system. So if you're in a heavy weather zone, if you've got a lot of production, then clearly you're going to want to put a lot of production, a lot of storage in. If you're in a benign area and you have market tankers coming and picking up things every other day, then you can deal with a little bit less storage. You can look at the economics of early oil. So with a conversion, potentially you should be able to get to early oil, and you should be able to manage the cost. You should be able to contribute to making it a cheap and cheerful, at least cheerful anyway, development. You need to look at maintainability. If you're going to leave that ship out there for 20 years and not disconnected, you need to be pretty damn sure that it's not going to suddenly find serious problems that need the ship to be dry docked to be dealt with. You have to be able to deal with the routine, things like cleaning the seawater box grids and things like that, without putting the ship into dry dock, and that means designing it for ROV work and various other things like that. So those are quite important requirements. Accessibility is important. You have to be able to look at the structure. You have to be able to get in and see the structure of the FPSO from time to time. I've talked about safety and comfort. There's an element of connection between the two. Floating production systems float. Floating bodies move. They move in the water. And actually, when you're moving people from having worked on a rig environment to a floating environment, sometimes they find it a bit uncomfortable and a little bit difficult. So you have to think about how you actually build the ship. And even, if I may dare mention a slightly indelicate issue, on one project I was involved with, the design of the toilets around the ship had a bit of a problem in that the toilet seats had a nasty habit of falling down when the ship rolled, and there was a lot of serious project work went on to look at how this could actually be avoided, and electromagnetic latches and all the rest of that sort of stuff were considered. When they asked the sailors about it, and in the keep it simple for sailors mode, we said two things. One is we always mount them fore and aft, so the roll doesn't affect them. And the second one is there's always a big bit cut out of the front of the loo, so if it falls down, it's not going to hurt anything. Anyway, moving swiftly on from that socially incorrect. The requirements drive design. I think it's requirements drive design, drive integrity. So this is just a sort of a quick idea of things that will make a difference when you're designing an FPSO. So when you get to field size, production and reserves, so if you've got a big field, lots of reserves, long life, then that's probably going to say to you, you're going to want a big FPSO, and you're probably going to design it from scratch. You're probably not going to try and shoehorn something on the back of an existing ship. If you look at environment, you look at wind and wave, you look at current, that's going to drive how your mooring system is designed, and actually the design of the ship. Because remember, a ship weather vanes, and to some extent you want the ship to weather vane in a particular way so that when you load onto a tanker, the tanker's sitting behind you in line with it, and that keeps the tanker away from the ship. So you need to think about those things. Tropical storms. What are you going to do in the case of a tropical storm? Are you going to evacuate the FPSO, or are you going to disconnect it and steam it away somewhere else? So these are things that will make a difference to the design. Legislation. Obviously, the safety case drives a lot of what's happening. There are things like accommodation, for example. Norwegian legislation now tends to push you towards the accommodation being at the bow, and the reason for that is that in theory, if there's a fire in the process plant, it will all head aft away from the accommodation, and that's a good idea. But there is a flaw with that, which I'll come back to. Does the hull have to be double hull? Tankers have to be double hull. In a lot of environments or a lot of places, people have chosen to I was going to say no, that's not the right word. I've chosen to get an exemption from the double hull legislation to allow FPSOs not to be built double hull. The reason for that is quite obvious. You don't need a double hull on a permanently moored FPSO, because if it runs aground, you really have a big problem. And in general, a double-sided ship is an awful lot more easy to maintain and look after and the likes of that. However, there may be environments where they haven't gone for that exemption. There may equally be a reason why you do want a double hull. For example, if it's a disconnectable unit, then that disconnectable unit can sail away as a tanker and can then sail close inshore. So you may well want it to be double hull. So that's another sort of issue that's worth thinking about. You might want to think about offtake. Are you going to use conventional tankers, or are you going to have a shuttle tanker? That makes quite a difference to the design of the ship and any machinery on it. Will it be operating as part of a closed system, or will you just be relying on spot tankers arriving to pick up stuff more or less on a random basis? Not totally. Distance from market makes a difference. And then in this there's a thing called offshore loading discount. If you look at any crude oil traded anywhere in the world, you'll find that crude oil is discounted in some way because of local conditions. Maybe if it's a port that's forever crowded. There is direct-to-market offshore loaded fields do tend to attract some sort of a discount because there may be weather delays in it. The ship may be late. There may be other issues that will mean that it's a less reliable source of oil than the ones from a conventional port. So offshore loading discount is something I will come back to again. And then that rolls into your design. What size of FPSO is it going to be? Is it double hull, double-sided, single hull? What size is the process plant going to be? Is it connectable? Is it disconnectable? Is the accommodation forward or aft? What's the mooring system? Is it spread mooring system or buoy mooring system? What's the offtake system? Do you want it to be weather vaning or spread mooring? I think I've just repeated myself there. Do you want it to be dumb or powered? You need it to be powered if you're going to disconnect. It's dumb if you don't need it to be. And that then brings you into a critical decision, or one of the critical decisions, which is about new build versus conversion. In the 90s, conversion was very much the way to go for a variety of reasons, which I'll explain to you. Things have moved on a bit. Let's talk about new builds. So a new build is a nice, new, clean hull with no history of fatigue or corrosion in it. So that's good. That's good news. It can be designed for the purpose. So you can build it strong enough to support double-decked process plant. You can build it double-sided to simplify structure and improve stability, and you can put the accommodation where you want. You can either put it forward or aft, and if you can also choose the size of it, because ships don't have big accommodation. One of the big problems you have with the conversion is the size of accommodation. The risks. Cost can get high. It tends to be a limited number of yards that do build these things. The cost of the hull can be to some extent compared with the cost of a ship, but not quite, because of a thing that I've described here as building yard process flow. Build yards like Hyundai and Daewoo and Samsung and people like that, who build a lot of ships, optimize around their building docks. And their plan is to get something in and out of the building docks in about 3 or 4 months, and then spend a bit longer fitting out the stuff that doesn't need the building dock. One of the problems with a non-standard unit is it could take more than 3 or 4 months. So what you effectively do is you could take up 2 of those building slots. So the yard is going to want a lot more money to spend more time in dock. They also don't like a lot of modifications. I was actually involved in a contract where we were offered a better price for not putting anybody in the yard. So the rather interesting sort of dynamic that, but the real reason for it, they say, was, well, you keep tweaking the design and keep trying to change the design, and when you change the design, then our entire production schedule goes to hell in a handbasket. Unique designs have unique risks. But one of the advantages of taking a sort of standard hull or a standard design is it's been out to sea and it's been worked, and people have worked out where the fatigue problems and all the rest of that are. There is a tendency when you look at building a unique hull to almost like start from scratch and say, well, actually, we're not going to build anything that looks like a ship because we don't need to. And that can cause a problem. When you get lots of sharp edges on a ship, for example, it tends to raise a lot of stress. Hull strength, you can think to yourself, well, actually, it's not going to be pounding through the weather, so it doesn't need to have as many supports built into the hull structure, and that has caused problems as well. And you can optimize on size, and there is an issue. I mentioned optimization of size because there's a little story I wanted to get into this, and that is one of the important things about the size of an FPSO is making sure it suits the offtake. You can spend an awful lot of time and effort to save not very much money in the size of an FPSO, and then find later on in the operation of that FPSO that you've created a massive discount for the crude because it's not quite the right parcel size for the ships that are going to be trading that market. I am aware of one FPSO in West Africa where they chopped out a bit of the hull and took it down to about 1.7 million barrels, when the normal trade size was 2 million barrels. So you then ended up with dead freight, which discounted the cargo quite considerably. So the fleeting pleasure that you get from a saving in building is quite often completely overwhelmed by the pain through the project's life as you realise that you made a mistake. Look at conversions. So reduced build time. I put a question mark there because it takes time to select an select a hull. It takes time to buy a hull, and it takes time to convert it because it may not exactly be what you think it is. Its good point is if you're going to do a disconnectable, then it's ship shaped and it's already engined, so that makes it a shoe-in for that kind of project. It's cheaper, and I put a question mark there, and I'll come back to that in the benefits. And it does have a history, but in the tanker business, because of the concerns about integrity of oil tankers, there is a lot of history available. Things called the enhanced survey process and the condition assessment process mean that you have a lot of technical data available on a hull before you actually commit to it. It doesn't replace having a really good survey. Let me look at the risks for conversions. There is a design risk when you're at FEED because you don't know what ship you're going to buy. You're not going to buy the ship up front, so you can make some guess as to what ship you're going to use. But the detail of the ship you'll actually use, you won't have it at FEED stage. Now that probably doesn't make a lot of difference because you may well just be worried about the supports and all the rest of that sort of stuff. The reason why I think conversions needs a lot of thought nowadays, in the 1990s, we'd just come out of a pretty depressed period in the tanker business. There was a lot of single hull ships that were built in the 1970s that were available for conversion into double hulls. That miserable period in the tanker business meant that in the 1980s, shipbuilders tried to find a lot of clever ways to make ships cheaper. They reduced the scantlings, they reduced the supports to a great degree. They also included high tensile steel in some hulls, and the high tensile steels didn't work particularly well, and there was a lot of cracking problems. they introduced a wonderful idea which is called negative rolling margins. Now, if you think about when you roll a plate to build a ship, when you roll that plate, there's a tolerance in it. So if you roll a 25 mil plate, there's maybe a tolerance of half a millimeter in it. But the rolling mills got so clever, they actually developed the capability to roll to the tolerance. So instead of a nominal 25 millimeter plate, they rolled the plate so that it was 24.5 millimeters. So you'd already lost some of your sort of corrosion and fatigue allowances and all the rest of that sort of stuff. So 1980s built ships, there is a problem. Be very careful with them. Single hull versus double hull is another issue. All of the 1970 ships were single hullers. From 1995 onwards, they were all double hullers. So if you want a ship which is less than 20 years old to convert, then it will be a double huller. If it's a double huller and one of the early generation double hullers, then you've got to be careful because some of them had problems with the original design because they were new, they hadn't quite worked them all out. And secondly, some of them had problems with stability because you have that tank down below. If you leave it empty, then it can affect your stability. So conversions, my view is the crop of ships that are available from conversions now compared with the crop of ships that were available in the 1990s is considerably less. Tank and deck repair work can be expensive, and limits and deck load are pretty much the same thing. If you're going to put something heavy in the deck, you're almost inevitably going to have to strengthen it in some way. If you do that, you may well have a look at the deck and find that there's a whole load of stuff there that needs to be repaired. Before you know what you're doing, you're ripping out the entire deck of the ship and costing an awful lot of money. So you need to be very careful in selecting a conversion for the weight that you're going to put on its deck. And then finally, accommodation, size and position. It's rather important to make sure that you've got enough accommodation for the people aboard. Ships don't have a lot of accommodation. They're not designed for a lot of accommodation. So any conversion, you're going to have to add accommodation of some sort. And it may well be that under a sort of Norwegian scenario, you may well have to put accommodation up for it. So a lot of those things, if you can see, if you add a lot of these things together, you think, why would I actually bother trying to convert something when I can build it from scratch? Let me talk about a couple of case studies which will help me to emphasise some of those points. One location, two solutions, Foynhaven and Schiehallion, both west of Shetland. The first development was Foynhaven. Foynhaven was a smaller field, was expected to be shorter life, and was developed under a lease arrangement. So if you look at the FPSO that was produced at Petrojar Foynhaven, it was a powered FPSO. It had limited storage, only 350,000 barrels, and originally ran with a couple of DP1 shuttle tankers. The logic of the power, it was a conversion. It was actually a Russian submarine transportation vessel that they converted, rather odd vessel. It was heavily powered, and one of the things they reckoned was that, they proved quite conclusively, was that by having it powered and having lower tech tankers, you could run the engines while you actually had the tankers behind, and that actually tensioned the tanker away from the ship. So that the model was different. Smaller vessel, smaller fields, conversion, leased, all the rest of that sort of stuff. Kind of said this was the right solution. The one on the right is Schiehallion. Schiehallion was a much bigger field, and Schiehallion was a designed and built hull, built in Harlan and Wolff's in Belfast, and had a much larger process plant, which probably made an awful lot of sense. It had a high-tech DP2 tanker behind it, so the FPSO could weather vane, and the high-tech DP tanker could quite happily move behind it. So you can see two different places, million barrel storage. So you had a fair amount of buffer in the system. One Another one that's worth thinking about, SCAV. SCAV, if you look at this one, you look at the forward accommodation, you look at the turret there, and the distance between the turret and the forward accommodation is determined by rule. One of the problems that you then get is that with that windage area up forward, then you actually need power to maintain the FPSO head into wind. Now, we did actually talk about putting big sort of almost like wings on the back, like a sort of 1950s American car, which would balance that out, but that would increase the mooring roads. But you know, just a point that legislation does have a part to play in this. I'm going to talk very quickly and very briefly about integrity of the offtake system. You've got the FPSO. You have a choice from the FPSO point of view of off-taking either via a shuttle tanker, and if you use a shuttle tanker, you have the option of using a transshipment port, or you have the option of taking it straight to market. If you've got conventional tankers, then you go straight to market. The use of conventional tankers means once they arrive, they go away again, and you never see them again. They're not part of your system, so if they're late at the next port, it doesn't make any difference to you. That tends to be used in benign environments. You may well use spread moorings. You may well have loading buoys a distance away from the FPSO. You may need tugs to help moor and all the rest of that sort of stuff. A shuttle is part of your dedicated system. If you're going to a transshipment port like Schiehallion used Sullom Voe, Foinaven used Flotta, if you use a transshipment port, then you've brought more storage into the system. And the oil that's being sold to the market is actually oil that is just coming from a conventional port, so it doesn't attract offshore loading discounts and the likes of that. If you're taking your cargoes for the shuttle direct to market, you probably need more than one tanker, or you may well need a contract of affreightment arrangement, as TK provide to a lot of people around the world. That just gives you an indication that the FPSO is not part of is part of a system, and you need to think about how the whole system works when you design it. I want to talk a wee bit about assurance, because it's worth talking about, and again in my simple sailor language, what does assurance mean? That means three basic questions. Is the design right for the field and the environment? Has the unit been built to the design intent? And is it being operated to the design intent? And if any of those change, then you move into a change management process. And one of the great problems with offshore developments is the tendency for people to change their views on things as the project goes through, and then not do a proper change management process. And before you know what's happened, you find flaws like the shorter ship that I was talking about earlier. Assurance, you need to be looking at the overall. You need to be looking at the overall risks. You need to be improving and developing the design standards and the construction standards to support integrity. You need to be capturing learning from the rest of the industry. You need to be looking at the competency of the people who work for you. You need to look at the operating procedures. You need to be very careful about the contractors that you select, particularly when it's a big contractor. And you also need to look, when you're in the offtake phase, at offtake vetting. And I've put a small sort of advert from moams in there. If you look at my website, there's a booklet on assurance, which is there for you to print off or shred, whichever you wish to do. Moving on, remembering the instruction to point to the back end. Okay, conclusions. Number and scale of FPSO developments are increasing. It's gone from a cottage industry to being very mainstream. Good FPSO design, construction and operation is a blend of offshore and marine disciplines, and I think that's an important point. Some of the early ones didn't have that blend, or it had a built-in conflict the way the organisations were set up. Field requirements, environment requirements drive the design. Those design choices drive the integrity, and you've got to go around the loop several times before you get to the right place. The integrity of the whole system is important. If your offtake system is under pressure, then potentially that offtake system can cause damage to the FPSO, quite literally. Assurance and change management during design, build and operations provides integrity. And finally, without the F, your PSO is sunk. So, any questions?
Thank you very much. Okay, any questions, please? Yeah. Let's start with Paul first, down the front. Terry. Yeah, just wait for the mic, because we need to preserve your words for posterity.
Paul Mean Infill Systems. I've got two questions. One is probably quite simple. For the permanently moored FPSOs, are they designed to the same criteria as platforms for regarding 100-year storms, that sort of thing? And the second one is, what are the main drivers for the turret design? For you have, internal turret versus external turret.
First one, yes, they are designed for the sort of 100-year storms. I think I'm right in saying, if I remember rightly, Schiehallion got 300-year storms in the first year of operation, but that's another issue entirely. So yes, they are designed to the same sort of Met Ocean requirements. I cannot pretend to be an expert on turrets. There's a number of different mooring options. Obviously, there's the external turret, which tends to be more towards a disconnectable type system. So you can take them away either short term or medium term, whereas the built-in turret built into the hull structure is almost invariably for a fixed system, albeit there is a thing called a submerged turret, which TK I think have got the license for, which is capable of disconnection and reconnection. But if it's integral to the hull, it's generally a permanently moored FPSO. If it's on the outside, it would probably be disconnectable. But I don't, if my words are preserved for prosperity, that comes with a massive health warning. There was another.
Yeah, Martin, back to you.
Martin Betton with TGS. Have you come across any requirements that consider the subsurface monitoring requirements that might happen over the 20-year life of an FPSO? It seemed very focused on the actual production plumbing.
Yeah, so I'll be honest and say I focused on the floating bit rather than the subsurface bit. So I'm not expert in that area, and I think I would be misleading you if I gave you an answer.
Okay. Bob, down the front here.
Bob Waterhouse, RG Petroleum. In terms of timescales, I think there are potentially two factors. You've got the lifespan, life expectancy of the FPSO itself, and you've got the life expectancy of the field. Now, those two things are not necessarily going to coincide. So in the situation where the FPSO is not some kind of universal thing that can be moved around from one field to another because of its specific design capabilities, what's the kind of matching criteria, metrics of those two different timescales, and how does that kind of matching process influence the factors involved in deciding whether or not you're going to modify an old tanker, which is going to have a reduced life, as opposed to build something from scratch, which might have a longer life than the field itself, and then what do you do with it when the field is actually depleted beyond the commercial production position?
So I think sort of several questions there. If I might answer the last one first. I mean, I think the key to it is that when you're making the decision about whether you're going to put an FPSO in place for the life of a field, then clearly it's got to be a big enough field to generate the cash flow to actually do that. So I think you'll find there's a trigger point rather than a sort of a continuum, if you see what I mean. Below that, then there is a tendency to go for something which is disconnectable either in the short or the medium term. So conceivably, well, not conceivably, practically any FPSO is disconnectable. It's just a question of how long. So you could still on a long life field, you could still take that FPSO away. Obviously, it'd take you 6 to 12 months to disconnect it, and you could still reuse it. So when you're doing the economics, you can take some account of that end of life scenario. Beyond that, you can go to the extreme. If you go right back to one of the earliest developments, there's a thing called Shallon, which is a single well oil production system, which was way back in the late 80s. And it was designed to go from field to field. It was quite literally going to the very smallest fields. So it was the opposite concept, which was the design was built around the unit, and you could access as many fields as you wanted with it. The likes of the Petrojarl one, which was the first of the what are now TK FPSOs, it was designed to be moved to another field. If you look at Petrojarl Foinaven, it was designed from the point of view that at some point it was going to leave that field and go somewhere else. So some of the design compromises were the result of that, the fact it was leased and the likes of that. Does that answer your question, or at least give you some?
Yeah, I think it does.
Right.
That's very useful.
Thanks.
Let me sort of follow up on that a bit, Martin.
Yep.
I mean, one of the, if you look at West Africa, from, I don't know, Mauritania down to southern Angola, you could say similar environment, similar water depth, similar types of reservoirs. And there is no such thing as a kind of cookie cutter FPSO. They're all different and all look as though they're, it's like, feels like you go along to the Ford Motor Company and they say, well, do you want 4 wheels or 6? The 2 steering wheels okay this time, sir? I mean, why is that inevitable, or what goes on in that discussion?
It's an interesting point. Yeah, I mean, I think you're right. There's no. We can define a whole load of principles, and you can be pretty damn sure that people won't follow them. I think the fact is that each individual company comes to it from its own history and has got its own things that it wants to add to it. In mooring systems, for example, if you go down to West Africa, as you say, you'll find some of spread moorings and some of buoy moorings, and the likes of that. So, in one case that I'm aware of in West Africa, they deliberately went for a spread mooring system, because that would then create the need for a loading buoy distant from the FPSO, because they could build that under local content. So there was a bit of cart driving the horse. So the whole bunch of other things which can influence you. I'm sorry, what was the second part of your question?
Well, it's really, why isn't there a cookie cutter approach?
Yeah.
I mean, does it just arise from individual companies? I suppose that you've answered the question.
I think to a great degree it does. I think there are. So I think if you look at the general principles, you can say if you're going to build something big and build something in deep water, you are probably not going to convert. If it's a big field with big production, it will justify you doing the new build from scratch. And when you actually look at the economics, you'll find that the amount of work you actually have to do on the hull will quickly overtake any savings you're going to get from it. Sorry, I remember there was another point that I wanted to make. Exxon, I think I'm right in saying Exxon bought a series of. No, they didn't. Sorry, I'm telling a lie. No, they didn't. They built a standard design for some of the Western Africa fields. So you'll find that after a certain point, the Exxon operated fields in Western Africa follow a roughly standard design. We also discussed that in BP as well. I mean, that's the thing I think that everybody's talking about, and that is, well, why can't you build a standard design, even a standard design hull? Well, obviously, the fields are going to be different. Some of them will be light crude, some of them will be heavy crude, some of them will require more dewatering. The actual stuff that you sit on the deck differs, but can you build a standard FPSO? And that I think Exxon has done. I'm reasonably sure they have standardized, but I'm not sure I know of anyone else who's done the same thing.
Yeah, okay. Anybody else? All right, Martin, thanks very much
Thank
for
you.
that. Okay, we'll take a break.